easterly direction. Easterly means what? What does easterly mean? It means to the right. Positive what? Positive what? Positive what?
It's like increasing.
What is increasing? The velocity is... The velocity is positive. The velocity is positive. The velocity is positive. The velocity is positive. That's what means moves in an easterly direction. It has nothing to do with the rate of change of velocity. That's concavity. So velocity positive means move east. So if this is a distance graph, if the function is increasing, that means the velocity is what?
Positive.
Positive. So where's that happening? From here to here and from where to where? Like 7.5 up like this. So that's where it's easterly. Are you okay with that?
Yeah.
Okay, so that's where the velocity, so that's where v of t is greater than 0. That's where v of t is greater than 0. That's also the same thing as saying s prime of t is greater than 0. During what time interval is Fred's walking in a westerly direction? What does westerly mean? What does westerly mean? What useful sentences? Negative velocity, exactly. Vt is less than 0, so s prime of t is less than 0. So let's use a different color for this one. So westerly, what's that going to be? Everything else, right? A particle is either moving in this structure, either east or west, or it's not moving at all, right? Got it. So are we okay with these two? Yeah. A and B? Got it. When is Fred's velocity greatest? So does velocity have a sign? Can velocity be positive? Can velocity be negative?
Yeah.
Can velocity have a sign?
Yeah.
Yes, it does. Speed is always positive. Velocity can be positive and negative, right? So where is it greatest? Where is it greatest? It's where the slope is going to be the most, not the steepest, be more specific, most positive. Most positive. So where is it most, where does it, this is challenging because it could happen in a couple places. Where does it look like it's most positive?
Like I saw 10 more than...
Yeah, it kind of looks like this might be
like 10 was
V prime.
definite, but like,
Yeah,
totally
so there's two here. It looks maybe 0. You have no way of knowing for this one, right? So either one would be okay. It looks like it's steepest when t equals 10 and it's steepest. And also it says when. When. Does it say where?
Oh.
Does it say where?
No.
No, it says when. So that's the x coordinate. No, when is just an x value on this because time is the x value. So that's why it's t equals 10 or maybe t equals 0. I would accept either one on that. It looks like it's either starting, it looks like this tangent line could be the same steepness as that tangent line. Does that make sense?
Yeah.
Why? So let's say this was super steep right there. Why wouldn't that be the greatest velocity? Because it's what? It's negative. Negative velocity is always going to be smaller than any positive velocity. It's not talking about speed, it's talking about velocity. When is Fred's velocity least? Well, that's going to be when, can velocity be negative?
Yeah.
Yeah, so it looks like when it's steepest, which happens, it would be anywhere, I would accept any answer on t equals 4.5. Like anywhere in here. Is it kind of impossible to tell by our eyeball where is it steepest?
Yeah.
It's kind of impossible. I would accept any answer around t equals 4.5, just like I did on the last quiz. When is this speed greatest? This is also challenging. Why is this challenging? Because speed is the absolute value of velocity, right? So it's where is it steepest, positive or negative? Do you have a definitive way of telling which one is steepest? There's basically what are the three candidates for this? 0, 4.5, or 10. I would accept either one of those because they look about the same when you take the absolute value, because that's what speed is. Speed is magnitude of velocity.
So we can say 4.5 and...
Yeah.
Right?
Yeah, you could say and. I would accept and. That actually tells me you're doing a full analysis.
Okay.
F, when is speed least? What's the lowest speed you can have? 0, because can speed be negative?
No.
So there's two places. What are they? Around 2 and around 7.5. These two places right there. Because that's where the slope is 0. So that's when v of t is what? 0. When v of t is 0. What's the smallest speed that you can achieve? 0, 0, 0. During what time interval is Fred's acceleration positive? Acceleration positive means what type of thing is going on the graph? Concave up, exactly. Where is it concave up? Where does it look like it's happy?
From 7.5 to infinity.
Well, it's more than that. It looks like it's concave up there, but is it still concave up here? If we said 4.5 was the inflection point, we would say it's 4.5 to infinity is where it's concave up. Concave up, smiley face, right? So where is it concave down? Everywhere else. Everywhere else where it's concave down, frowny face. So where is the acceleration positive? It's positive from 4.5 to what? It says 10. Now, you say 10 if this graph stops at 10, right? If you say stops at 10, it would be there. If there's no arrows on the graph, everybody, stop it where it stops. On the test, if there are no arrows, don't assume it keeps going. It stops there. So it would stop at 10. It would stop at 10. So where's the acceleration negative? The acceleration is negative for concave down. So that is, what color did I do there? Green? Yeah, green. 0 to 4.5. The most challenging parts of these, I think, are I and J. Do you remember what has to be true for something to speed up? What does speed up mean? Speed up means what?
Accelerating.
Velocity and acceleration have what? Same sign. Exactly. So what does slowing down mean?
Opposite direction.
Yeah. Slowing down means V of t and A of t have what? Different what? Different sign. So you look at the graph and you find out where do they have the same sign and where do they have a different sign. So you see the 4 colors there? You see how I used 4 different colors? This meant what? F double prime is less than 0. What did this mean? F double prime is greater than 0. What did the yellow mean? F prime of x is greater than 0, right? So that's F prime of x is greater than 0. And what did that mean? F prime is less than 0. So where are they both negative? Where are they both negative?
From 1.75
to 4.5, right? And where are they both positive? 7.5 to 10. So that's why this right here means they are speeding up because they're both going in the same direction. Can you speed up going forward? Yes. Can you speed up going backwards?
Yeah.
This is actually a really interesting problem with interstellar space travel. So we think about interstellar space travel as we have to go really far to get to another planet, right? We have to go really far to get to another star. So in order to get there in any sort of human lifespan, we have to go really, really, really what? Really fast, right? So we always think about it in terms of acceleration, right? We think we need to get that fast. But what else is it really important to do? What's just as important? If you get going really fast, if you want to get there, what do you also have to do?
Go in my direction.
Yes, and what else? What happens if you accelerate to 1 billion miles an hour and then you get to Mars? You also have to slow down. Slowing down. This is really important, everybody. We think of like breaking orbit and getting up to a really fast velocity as the hardest part about space travel. What's just as important? Slowing down, literally. Literally. Like what happens if you don't slow down to the perfect speed? Boom. I like that. That was actually a really good pitch. Boom. Anybody see The Martian?
Yeah.
Did you read the book? Read the book. There's a lot more in it than they have to. Of course, they have to cut stuff out. It's a fantastic translation of the book. But if you talk about space travel, how much time do you spend slowing down compared to speeding up? Generally speaking, what do you think? Take a guess.
2 times.
What? What'd you say? The same. What happens if you slow down too much? Too fast, I mean.
You don't make it.
Oh, okay. What happens if you accelerate too fast?
You'll crash into the...
No, what happens if you just blast off from Earth at like 100 Gs? What happens?
It disintegrates.
You literally, what happens to you?
You die.
You die. You turn into jelly, right? We have no way of fighting against inertia, right? So when you accelerate really quickly, what happens in the back of my chair if I start moving? It starts pushing into you, right? So what happens if I accelerate to 5, 6, 7 Gs? It hurts a lot. Jet pilots wear suits. You know what those suits do to them? Literally, do you know what jet pilot suits do to them?
Keep the
They
pressure
push
in the
out. Yeah, they pressurize. Right?
They're pressurized, but the thing is, there's no such thing as beating inertia, everybody.
Right.
You can't do anything to beat inertia. Do you understand what I mean by that? Like if you're moving, if something is pushing against you, is there anything that negates that? No, the only thing that negates that is something pushing against you the opposite way. Great, crushing you, right? Jet pilots wear suits that keep their circulation moving. You pass out when you hit 6, 7, 8 Gs because your heart can't pump blood to your body, right?
Big breathing patterns.
Breathing patterns, all sorts of stuff, right? So think about this, like if you accelerating too quickly is just as dangerous as decelerating too quickly, because guess what? Deceleration on your body is the exact same thing as what? Acceleration. It's the exact same thing. So it's really hard. So when you talk about big time space travel, one of the things you have to calculate, which is super interesting to think about, at least I like to think about it, is this fuel to mass ratio. It's super interesting to think about. So when you blast off when we blast the shuttle into space, or the next shuttle, whatever the next thing is, there are those big fuel canisters on the side, right? And eventually the spacecraft gets to orbit, those things fall off as they come down, and then it comes back down using friction to slow it down, right? Here's the thing. When the shuttle blasts up, how much does it weigh with the fuel compared to how much it weighs when it gets to space? A lot more. Thousands, like hundreds and hundreds of times more than its final, right? So if you want to get like 1 pound of stuff or 1 kilogram of stuff into space, you generally need like 100 kilograms of fuel. Seriously. You generally, it's like, I think it's 100 to 1 or something like that, or more. So when you're putting something big in space, how much fuel do you need? A ton of it. So how do you solve that, by the way? So let's say you get something into orbit, which is the hardest thing, right? Breaking orbit is the hardest thing to do, and staying in orbit is the hardest thing to do. Once you get into orbit, is it really hard to get fuel into orbit? Yes, it's really hard to get fuel into orbit because fuel right now is either nuclear or it's burning fuel. It's hard to get into orbit. So how do you solve that? What's one way you solve that?
Because you need, fuel is going to
Cost you 100 gallons.
Velocity and not distance.
It's velocity and not distance. Okay, the same question, so you answer them the same way. During what time intervals is Fred walking in an easterly direction? Can you tell me what the definition of easterly direction is? It means positive velocity. V of t is greater than 0. So can you tell me where V of t is greater than 0? Here. That's literally where it's greater than 0. From 0 to 4. That's literally where it's greater than 0. So we're going to finish this. Hold on. Let's finish this one and then go back and see if you have questions. This was position, so you had to actually find where the slope of that was positive because that's velocity. You are now looking at the velocity graph. Okay, so where is this thing going to be doing westerly? Well, that's where the velocity is what? Negative. That is where V of t is less than 0. That's the blue.
These are actually kind of easy.
As long as you keep it straight in your head. It cranks through it. Is it really easy to muddle it up? Absolutely. Okay, so we did A and B. Are we okay with A and B?
Yeah.
Okay, C says, when is Fred's velocity greatest? That is literally the velocity graph, right? So where is it highest?
Maximum.
And remember, it's asking, you see this? When? When is that?
1.7.
We said that was like T equals what? 1 point what? 7.5. That's... Yes, I would accept 2. Yes, I would accept anything close to 1.75. I wouldn't accept things like 4 and 1 and 10. But yeah, do not sit there being like, oh my God, is it 1.8 or is it 1.81? It's like kids who graph stuff and the first thing they do is like, no. I understand estimating is a pain in the butt, but please don't. You have any idea how many hundreds of times I've seen that? You get hard-coded into making your scale. Like, you don't even know what points you're graphing, right? Yeah, it's like kids who graph stuff, like, and they're like, the graph is up here and their window is here, and they're like, I can't see anything. I'm like, yeah, no kidding. Okay, are we okay with C? Are we okay with C?
Yeah.
You have no idea how many times I've seen that. No idea. When is Fred's velocity least? Well, that's literally the velocity graph, so where is it least? 7.5. Are we okay with these 4?
Yes.
Okay. When is Fred's speed greatest? Speed is the magnitude of velocity. So that's the absolute value of velocity. So where's the velocity, if you took the absolute value, going to be the greatest?
7.5.
7.5, right? Because if you wanted to think about this, take the absolute value of this graph. What does the absolute value look like? This, right? Or that's not quite that high, right? What does it actually look like? It looks like kind of like this.
Technically, the scale is different. Oh, wait, no.
No, it's the same on both top and bottom, right? So the point is, where's the speed greatest? 7.5. Because what does speed equal?
It has no direction, so it's just...
The absolute value of velocity, right? Are we okay with that? When is Fred's speed least? Again, though, speed, what's the least speed you can have?
0.
So how many times is speed equal to 0 here?
3.
3 times, right? 0, 4, and 10. Are we okay so far?
Yeah.
So again, when we do G and H here, during what time interval is Fred's acceleration positive? Acceleration is the first derivative of velocity. So where is it positive? That's going to be where the derivative is positive. So that right there is where V prime is what? Positive. What is V prime equal to? What is V prime? V prime is what? Acceleration. So where is that true? It's from 0 to 1.75 and 7.5 to 10. That's where the velocity is increasing. Does everybody see that on the green? Do you see that on the green, everybody? Because what is V prime equal to? Acceleration. I don't know. What is your name? Stacy! You're like, no. Thinking about it too much, man. Gripping it too hard. So look, during what time interval is Fred's acceleration negative? Acceleration is negative when the v prime is negative. Where is v prime going to be negative? That is where v prime of t is negative. That's where acceleration is negative. So that's 1.75 to what? 7.5. Then you need to go back and say, what does speeding up mean, everybody? What does speeding up mean?
Concave.
Velocity and acceleration have the same sign. Velocity and acceleration have the same sign. So where's it slowing down?
Different sign.
Can I have a full sentence, please, Trebek? Have different signs. When velocity and acceleration have different signs. So then you need to go back here and go, remember which is okay. So let's look at this right here. We have v prime is greater than 0, right? And greater than 0 here. Well, where's it also? Where's the so that's where v prime is greater than 0, right? V prime is what? Acceleration. Acceleration. So v prime is greater than 0 right here, and velocity itself is greater than 0. You see the yellow right there? So that right there represents 0 to 1.75. It's also 4 to 7.5, because look what's happening from 4 to 7.5. What's this blue represent? The velocity is negative, and what does this purple represent right here? Acceleration is negative. Velocity is negative. So the way you get back to this, these are complicated only if you don't remember what it means for speeding up and slowing down. Speeding up means same sign velocity and acceleration. Literally make a table and see where they overlap. That's it. Natalie, yep.
Can we use highlighters on the test?
Absolutely. Absolutely. Yeah, sure. You want to use highlighters? Absolutely. I will let you use highlighters. Absolutely. It gave us the derivative. Is it important to recognize it's the derivative? Yes. Is the derivative of some function. The function f of x has two turning points. Find the x coordinates of the turning points. What are turning points?
Max and min.
Yeah, max and min. So it goes from, it's either a max or a min. Correct, it turns. Exactly. So to find maxes and mins, they can occur when the derivative is equal to what? They can occur when the derivative is equal to what? You've literally done this 100 times. 0. So you have x squared minus 10 times 2 to the x equals what?
0.
So there are two things being multiplied together there. What are the two things being multiplied together? X squared minus 10 and equals, so we set them equal to 0. So x squared is equal to 10, so x is equal to what? Plus or minus root 10. This one over here, 2 to what power equals 0? Any solutions to that? Nope, there are no solutions. There are no solutions. So where could the two turning points occur? Positive rad 10 or negative rad 10. We don't know if they're turning points yet, but we do know they could occur there. They could occur there. It says, find the x coordinate and turning points and decide which is a max and which is a minimum. So what do you look at if you're going to do that? If you want to determine if you want to decide if it's a max or a min, you could do it with concavity, but to do concavity, you need to look at the what derivative? So to do concavity, you need to take the derivative of this. Do you have any idea how to do the derivative of this?
No.
You could, but you'd need to use a table and your calculator and a table, right? You could. Now, you could use the first derivative. If something is a maximum, you are increasing to it, and then you are decreasing. So what are those two values there? There is positive root 10, and there's what? Are there any other places where the derivative is 0? Are there any other places where the derivative is 0? Hold on. Are there any other places? No, there aren't. So what do you know about these three regions? There's the green region, let's say the yellow region here, and then the purple region right here. The entirety of those regions have to be positive or negative. They can't switch, because if they switch, there'll be a 0 somewhere in there. So what do? You literally just plug in numbers to find out if it's positive or negative. Let's do the yellow one. What's between negative 10 and 10? 0. So let's just choose to test 0. Plug 0 in there. What's f prime of 0? That's going to be 0 squared minus 10 times 2 to the 0. That's negative 10. What's 2 to the 0? So what is that? So is it positive or negative in between there? So it's falling. The derivative is negative there. What's to the right of the square root of 10? What's an square root of 10 is a little bit bigger than what? Yes,
3.
What is 3 squared? What is 4 squared?
16.
For reals? 4 squared is 12? Like, for reals? 4 squared is 16. So what number do you want to test over here? Yes, that is... Okay, no. That is totally fine. You can go bigger. Whatever you want to plug in, right? Plug in 10 if you wanted to. What could you plug in down here? Negative 10. So over there, so what's f prime of 10? Well, that's going to be 10 squared minus 10 times 2 to the 2 to the 10th. That's fine. Do you care what it actually equals?
No.
You only care if it's that is definitely what? So it's definitely positive, right? So then let's do f prime of negative 10. Well, that's negative 10 squared minus 10 times 2 to the negative 10th. Well, what is that? What is this? That number is what? That's big, right? What's negative 10 times negative 10? 100. 100 minus 10 is 90. So that's going to be 90. 2 to the negative 10th. Is that positive or negative? It's positive. So this is small, but what is it definitely? It's definitely positive. So what is it over here? So this function is it's rising all the way to negative 1 square root of 10, and then it's going down, and then it's going up. So what's happening here? A max, and what's happening here? A min. And it says points, right? Have we found the point yet? The original. Oh, wait a minute. We don't know the original, so can we actually find the points? No, it says just find the x coordinates. You can't find the actual points on this one. So you would say max occurs where? When x equals negative root 10, because it goes from rise to what? Fall. And then min occurs when x is equal to root 10, because it goes from falling to rise. Does that make sense? And do you understand why we can't find the point?
Yeah.
All we know is that this function does something like this, right? And where do those occur? X equals negative root 10, and what's this? X equals root 10. But do we have any idea how high or low this thing is? This thing right here, where could that be? Anywhere up like this, right? Does the derivative change if I rise it up there?
No.
Does the derivative change if I put it down here? No, the derivative doesn't change, but where this point is, does the location of that point change? Yeah, so you will need to later have an initial condition. Like I'll tell you, like we'll fix it at a certain point. Like if I said it's stapled to this point right here, what are we going to do? We're going to take this whole curve and do what? We're going to raise it all the way up until what happens? It touches that point. But we're not there yet. We're not integrating it. We're going the derivative direction. We're not going backwards. We're not going backwards yet. Okay, so you can use this time now.